Currying means taking an existing function that accepts two or more parameters and returning a new function that accepts exactly one parameter, which, when called, returns a second function that accepts exactly one parameter, and on until the final function evaluates the end result. The classic example of this that you'll find online is an addition function. This isn't too hard to understand, but what trips most people up is that the practical applications are not immediately obvious. Most examples will show you something like this. Here, the curried function is called with the first parameter to create a new function called add5, which will add 5 to whatever you give it. One thing to note is that this example actually is not an example of currying. It's an example of a pattern that's common in functional programming called partial application. Currying and partial application are often confused. That's because currying is a technique for taking existing functions that are not capable of being used for partial application and creating new functions that can. And it's also the most common reason to use currying. You might be interested in how curry functions work, so I've included a link to an article that shows you how to build one. But existing libraries such as Ramda give you pre-made curry functions should you ever need one. Back to the example, this does show you what currying and partial application is, but it's not an example of something you're going to find in the real world.
That's just stupid!
So let's say you have a string of text and you want to highlight every substring matching a user's search, but only in cases where it's at the beginning of a word. In an imperative approach, you'd probably build a string one word at a time using a loop. But in functional programming, we don't like temp variables because we favor immutability. We can use array.reduce on our array of words instead of the loop. But the callback to reduce can only accept two parameters, the accumulator and the current value. So how do we give it access to the search term, especially if we don't want to create nested functions?
Oh no!
Well, we can create a function that accepts the search term and then returns the accumulator function. Then, in our call to reduce, we evaluate our function by giving it the search term, and that returns our reducer function with the search term applied. And well, you might say, wait a second, the function that getReturned still takes two parameters. I thought the final function was only supposed to take one. The important thing to note is that the final function returns the final evaluated result, and in this case what we want is a reducer function. So while this is not an example of currying specifically, it does show the important functional pattern that currying makes possible when you're dealing with existing functions that take multiple parameters.
Where do we go from here? Where do we go from here?
There's a really great article by Scott Soyet called Favoring Currying that I recommend you read for more information. In it, Scott gives more real-world examples, including how currying and partial application can be used to greatly simplify promise chains. Scott Soyet is one of the devs behind Ramda, and even though I don't find myself ever needing to use it, the documentation on their website is a goldmine of information about currying and functional programming in general. I've included links to everything in the description. And as with all the videos on Speaking in Code, I've also posted the source code to these examples, complete with unit tests, to my GitHub so that you can download and play with them. And that's currying explained in 5 minutes. Hey, thanks so much for watching. If you enjoyed this video, please remember to like and subscribe, leave your comments down below, share on social media, and all that fun stuff. Until next time, this has been Speaking in Code, switching back to English.